find dy over dx if x cubed plus y cubed equals 6xy. This equation actually gives us a graph that is one that is named, and here it is. It's the folium of Descartes, which I can write out for you. Folium of Descartes, which you can look up online if you want to learn more about that. But what I want to do is I want to find the derivative. And here we have an equation with x and y, and it's not easy to solve for y and write it in terms of x. So this is a scenario where we want to use implicit differentiation. And remember, with implicit differentiation, what we want to do is we want to differentiate both sides with respect to x. So we want to have d over dx of the left-hand side, x cubed plus y cubed, and have that equal to d over dx of the right-hand side, 6xy. Right? Over the course of the math classes that you've taken, you've done so many things to both sides of an equation to get a new one. You've added or subtracted the same number on both sides. You've multiplied or divided by the same quantity. You have squared both sides of an equation, etc., etc., etc. And one other thing that we can do is we can differentiate both sides. But the thing we have to be careful about here is to recognize that we are differentiating with respect to x. And because we're looking at the derivative, which is the rate of change of y with respect to x, we are going to consider y as a function of x. All right? Y is not just a variable, it's actually a function of x. That's how we want to consider it. And so anytime we have a y in the problem, in the equation, and we are differentiating with respect to x, we need to use the chain rule and consider y to be a function of x. So let's go through and differentiate both sides. The derivative of x cubed with respect to x is 3x squared, plus, now we're differentiating y cubed. This is a composition of functions, so we need to use the chain rule. The derivative of the outer function y cubed is 3y squared. But then we have to multiply by the derivative of the inside. And the derivative of y we can express as dy over dx. Now let's look on the right-hand side. We want to differentiate this quantity with respect to x. We're actually going to have to use the product rule, because we have a product of two functions. I'm going to let the first one be 6x and the second one be y. Now when we use the product rule, we've got the derivative of the first function times the second. So the derivative of 6x is 6 times the second, which is y, plus the derivative of the second factor times the first. Well, the derivative of y with respect to x is written dy over dx times that first function, which is 6x. So we've done the first step, differentiating both sides with respect to x. Now, to figure out what the derivative is, dy over dx, we need to isolate dy over dx on one side of the equation. So what I want to do is I want to take this term that has a dy over dx, and I want to subtract it so it moves to the left with the other term. And I'm also going to subtract 3x squared from both sides to move it to the right-hand side, so that we'll have all the terms with the dy over dx on the left and everything without on the right. So we've got this 3y squared dy over dx on the left, and if we subtract this other term from both sides, that's going to move it from the right to the left. That's going to be minus dy over dx times 6x. And then on the right-hand side, we've got this 6 times y, which is just 6y. And we also want to move this 3x squared to the right-hand side. We do that by subtracting 3x squared on both sides, So that's going to become a minus 3x squared over there. All right, now we want to get dy over dx alone, so we're going to factor it out on the left-hand side. So that's going to give us dy over dx times the quantity, 3y squared minus 6x. And then on the right, we've got equals 6y minus 3x squared. And if we want to get the dy over dx alone, we need to divide both sides by 3y squared minus 6x. If we do that, that is going to isolate the dy over dx, and we're going to have on the right-hand side the 6y minus 3x squared divided by that 3y squared minus 6x. And there is one thing we can do to simplify. We can recognize that the numerator and denominator are both divisible by 3, so we could factor out those 3's and then cancel them, or we could just divide the top and bottom by 3. Either way, if we do that, that's going to give us 2y minus x squared in the top and y squared minus 2x on the bottom. And that is going to be our derivative dy over dx.